Building medical diagnostic software has historically required massive capital. Major tech corporations pour millions of dollars into highly restrictive, isolated environments, battling through years of regulatory red tape just to get a single scanning tool into a clinic. Complex software engineering now takes place on consumer laptops. In 20 minutes, a solo creator can match the technical output of a small engineering team, building a sophisticated visual scanning AI app for exactly $0. To understand why this matters, we have to look at chronic conditions like diabetes. Consistently high blood sugar creates severe, highly visible physical complications. Patients regularly suffer from foot ulcers or diabetic dermopathy, which causes localized skin degradation. Monitoring these distinct visual changes is vital, but difficult for the average patient. Historically, analyzing tissue degradation meant paying for frequent in-person clinical visits, or relying on those expensive, tightly controlled medical software networks. AI coding agents are bypassing that corporate bottleneck. The capacity to build these complex diagnostic tools is now sitting directly in the hands of everyday people. The creator starts by establishing the underlying logic. Instead of writing code, he types plain English instructions into Gemini, an artificial intelligence model, telling it to map out a mobile application that analyzes human selfies. From a simple text prompt, the AI maps out the architecture, branching into 8 distinct phases. With the logic defined, a secondary tool transforms these nodes into detailed UI wireframes, building the visual layouts humans interact with. Stitch instantly generates both the modern visual interface and the underlying HTML. HTML is a standardized code that allows a computer to display text and images on a screen correctly. Typically, a software company would pay a professional designer thousands of dollars to meticulously draft these layouts. The complex foundational logic and the high-end aesthetic design of a mobile application have been entirely engineered using casual, conversational language. The final assembly happens inside VS Code, a source code editor where developers write and debug software. Here, the creator sets up the Flutter framework. Flutter is an open-source toolkit created by Google, allowing developers to build natively compiled applications for multiple platforms from a single codebase. Inside this environment, the creator activates a specialized AI coding extension. This tool functions exactly like an autonomous, tireless junior developer, waiting for its instructions. The creator pastes his initial English prompt directly into the AI agent, hits enter, and removes his hands entirely from the keyboard. The agent takes total control. It autonomously downloads software packages, constructs the system directories, and writes logic line by line. Minutes later, a functional cosmetic app boots up on an Android emulator. This virtual device runs directly on a computer, perfectly mimicking the hardware and software of a physical smartphone. The manual labor of development has been automated. The human in this workflow functions as a director, managing the AI as it executes the technical build. The cosmetic app relies on a 3-step pipeline: camera input, AI visual analysis, and a recommended action. This pipeline is mechanically identical to a medical-grade diabetic wound tracker. The camera targets a human foot, the AI scans for anomalies, and generates a medical alert. A patient or a caregiver can duplicate that exact 20-minute workflow. By altering the text prompt, they can instruct the AI to output an application specifically designed to track the daily healing progress of a foot ulcer. They could modify the prompt further, commanding the AI to flag minor skin pigmentation changes. The camera becomes a localized early warning system for dangerous insulin spikes. An architecture originally designed to recommend makeup routines and generate passive ad revenue can be instantly repurposed into a highly specific, localized health monitor. The software tools required to execute this pivot are currently free. Creators are currently running public boot camps, teaching everyday people how to sequence these text prompts to build customized tools. The ability to build software without code solves a critical problem. It removes the friction between a life-saving idea and the functional code required to execute it.